Good morning, everyone. How's everybody? Surviving the snow? Very messy. Very messy, very messy. But tomorrow will be a clean day. Cold but clean. I would rather have cold than messy like this. Okay, so yesterday we have covered reading text file, writing to a text file. We have seen how to use JSON. We have seen how to write to JSON. And hopefully you're going to follow through on the exercise. And you're going to see how to read from JSON. So just want to reconnect a little bit with the exercise there. Just want to mention. So the exercise is available there under week 4. So you can see exercise 4 there. The solution for that whole exercise I'll provide tomorrow together with videos. Okay, so now, again, I will not be walking through here this exercise step by step. You're going to be reviewing on your own. If you have questions, come to me. So this course, and the course that I teach in general, it will ask you to do things on your own and to do things together with me as well. So those are some of the things that you're going to be doing on your own. Now, again, I provide solution, I provide the instructions, the videos, my videos on how to put together exercise. But if you still have questions, that's fine. Just come to me either during exercise in class or send me an email. As I didn't understand this part here, let me know, okay? Today we're going to be moving forward. We're going to be moving forward towards inheritance, and we're going to be mixing inheritance with exercises. That's under week 5. So those exercises here under week 5, I'll also be asking you to take care of them at home. There will be no bonus this week. You can take from now until next week to do those exercises. Again, practice them, because the test will have a similar format, okay? And again, for this one as well, I'll provide the solutions, I'll provide the videos explaining how to do it. You follow through. If you get stuck, I'm here, okay? Okay, so I'm gonna keep Padlet open as well. If you need anything there, let me open it here too. Okay, so as I mentioned today, we're going to be starting inheritance. I just closed the door just to give us less noise, but again, if anyone needs to leave at any time, I mean, that's all good. So inheritance. That was the video as well that I asked for the bonus. Who had a chance to look at the last bonus that talks a little bit about inheritance, okay? So we're gonna be talking about that today. More specifically, we're gonna be talking about what is inheritance, what is the use of inheritance. As part of inheritance, we're gonna be extending classes. Extending classes means that the class already exists, but we're gonna be building on top of that class, okay? We're gonna be building more things towards that class. We're not going to be changing the class. We're going to be extending, creating a new class based on the existing one and making improvements, making changes. The protected keywords, we have looked at that a little bit before. Today we're going to be looking on that further, because protected really becomes clear when you know about inheritance, when you know about parents and child classes, because protected will allow a member to be accessible not to the outside world, but to the descendants, to the children of that class. We're going to be talking about that. We're going to be talking about how we can override a behavior that is presented in a parent class, and the child will say, no, 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 I don't want to do that. I want to do something else here. So the child can override the behavior of the base class. We're going to be using this expression, is an, is a. A student is a person. A professor is a person. A cat is an animal. When we are talking about inheritance. We're going to be talking about the object class as well. Object class is the parent of all, is the godfather of classes. Every single class that you declare, if it doesn't inherit from somebody else, it's inheriting from object. And I'll mention that as well. So in terms of why inheritance is important, well, I can tell you this. Inheritance is one of the key cornerstones, one of the key elements of object-oriented programming. This idea of one class being able to come from another class. You have this in Java, you have this in PHP, you have this in C#, you have this in, I hope that in Python, I don't know in Python, but there must be some object-oriented programming there as well. But in all modern languages that you're going to be working in the job market out there, you're going to see object-oriented programming, and you're going to see inheritance as well. Okay? So we're going to see specific things about C# here and inheritance, but there will be key concepts that you're going to be able to apply them to Java, to any other language that you may work with. Okay? What we're going to be talking about today is available on chapter 10 of the book. Again, another great source for exercises. For some of you, some of what we discuss here may sound a little bit too basic because you have some advanced knowledge. That's fine. That's okay. So go to the book, go to the end of the chapter, take care of the exercise there. If you get stuck, come back to me and we can work it out. Okay, so I want to make sure that there's something for the more advanced students here as well. Okay, I want to start with this question. What comes to mind when you think about inheritance? Forget about coding. A child? A father and child. Yep. Anything else comes to mind when you think about inheritance? The money, the cash, yes. Goods, yeah? That's inheritance as well, you know? What else? Anything else comes to mind? Let's think about biology. Let's make it a biology class here. Genetics, yes. We are inheriting the genes of our parents, isn't it? We are a mix of both of them. And that's what we are doing with inheritance in coding, programming as well. We are inheriting things from this, a subclass is inheriting things from the parent class. So yeah, you're right. Money is one. Genetics, as someone said. Culture as well. We inherit culture from our family as well, from our parents as well. And again, that's what inheritance means. Inheritance means that we are gathering information, behavior from our ancestors. We are inheriting knowledge, information, data from a more general category, like animal to a cat, to a dog, or person to a student, to a faculty, or what else? Let's think about another one here. Like the one from the exercise, you have a vehicle for the bonus. You have vehicle, and then from vehicle we have a car, and we have a truck. And then from a car, you may have an SUV, you may have a sports car. So again, you start to see a hierarchical structure there with many levels of ancestors. Not sure if you remember that, but our first slide, one of the first slides when we were talking about UML, we saw that little diagram there of a person that we have a child called student and a child class called professor. They both inherit from person. Look at how the diagram describes that. It describes with a continuous line and a pointy white arrow pointing to the parents. Okay? So what this means is that student is a child of person and professor as well. If we go from top to bottom, what we have here is we have specialization. So a person is more generic than a student, than a professor. And then if you look from bottom to top, what you have is generalization. It becomes more general from a student to a person. It becomes more general from a professor to a person. So that's how we portray, we describe, we draft a diagram that has a relationship of inheritance between different classes. Okay? Looking at this, do you think that you're going to be able to say student.name in our codes? Do you think you're going to be able to say that? Student.name? We should. How about professor.email address? Yeah. How about student.salary? No. Okay. How about person.average mark? No. Okay. So again, the children, they not only see what is specific to them, but also what they inherit from the parents, what is available in the parents. However, the parent cannot see what's available in the children, nor amongst the siblings. Let's talk about siblings here, okay? So we have general information that is available to both of them, but we have specific ones here as well. That is only applicable to students, that is only applicable to professor, okay? So things that you may come across during the course, during exams, doing assignments, you may see a diagram like this. And now you know that we are talking about inheritance there, okay? Some of the advantages of inheritance. Why bother with inheritance? I mean, what's the big deal with that? Well, it can save time. It actually saves time. With that in mind, saving time, how do you think that we are saving time by doing this here? Can you give me an example of why we are saving time? Because of? Okay, let's not touch on that keyword yet. We're going to talk about that a little bit later. Brandon? Because you don't have to rewrite? Yeah, like those properties. You have saying something? The method as well, the method here?
Yeah, if both the classes can use anything.
Yeah. So we are not rewriting all this information over and over on students and in professor as well. We're not duplicating codes. Coding is about coding less, not coding more, not duplicating codes. So inheritance is a way that you can reduce codes. If you look at the second point there, it talks about reduce the chances for errors, of errors. Why is that? Because now we only have one set of code here for person. We don't have person duplicated here in student, duplicated here in professor. We don't have two sets of code to maintain. We have one single set of codes, okay? The life of a coder, the day-to-day job of a coder, of a programmer, of a developer, You may think that we are always creating new codes. How much do you think that in your time as a coder, if you become a coder, if you want to become a coder, how much time do you think that you're going to be working on creating new things? Any guess there?
I think it's debugging, right?
Debugging is not creating new things.
Yeah.
Debugging is working on existing codes.
Not as often as it first appears because you've written something, right, and it has a certain function, and you have that same functionality that can be used in a project, you just modify it instead of just running it all over again.
So I can tell you this, roughly, and again, this is just a rough estimate, but roughly, only 20% of your time will be creating new things. Majority of your time will be troubleshooting, fixing, maintaining code from somebody else, or even code that you may have created yourself. It's not very often that we get to work on a brand new functionality, okay? And why am I saying that? I'm saying that because if the code that we create is smaller, there's no duplication there, it becomes easier to maintain. It becomes easier to understand as well. And again, inheritance, it all goes back to why using inheritance. Again, it makes it easier to understand the inherited class. I mean, think about this. If Parson was already developed and you were working with Parson before, you know how to work with that person, with that class. And if you have a class that inherits from Parson, you only have to get to know how to work with this new class. You know already Parson. You just need to get to know how is it supposed to work with a new class. Makes it easier to write programs. Yeah, we can say that as well. This video here is the same as the bonus, so I'm not gonna play that video. The PDF is already on week 5, so you can open there. You can click on those icons. They are all active, those video icons, so they will point to videos on YouTube. Let's talk about terminology a little bit. And let's see what are the different terms that we use to describe the parents and the children. Because there are different terms that you may come across during exercises, during assignments, during tests. First one, for the parent. For the parent, we have base class. We can call it base class. You can call it superclass. You can call it parent class. You may come across any one of those terminologies. Okay? Base class, superclass, parent class. Sometimes when I read base class, I have to think twice and say, oh, because I think of base as the bottom one, but it's not the children, it's the top one. It's the base class of the other ones. Okay? And then we have the terminology that we use to describe the child class, the subclass, the derived class, the extend. Actually, if I say, actually it's already right here, extended class. Okay, so extended class is the children as well, the child. Okay, so derived, extended, subclass, child class. They inherit from. We use this terminology, SA. A car is a vehicle. A truck is a vehicle. A cat is an animal. So we use this description, this word, this combination there, to describe the relationship between a child and the parents. This SA. If you cannot use SA or SN, it means that they are not child and parents. Okay? If you cannot put in a phrase like that, like a sports car is a car. Okay? And then we also have ancestors. We don't have just two levels. It's not just the parent and the child. We may have the parents of the parents of the parents of the parents. Okay, so we may have grandparents, great-grandparents there. Okay? The point is that the most basic, the most inherited class will inherit all properties and methods from all its ancestors. It doesn't matter how many levels you have there. Everything before, every class that came before that one, it will inherit all of the properties. And again, when we are defining our classes, we don't define, usually we have not defined it so far, that they are inherited from another class. But they are. All our classes that we have created so far, they all inherit from one class called objects. Okay? We're going to see more about that a little bit. But the key word here is transitive. Transitive just means that the children accumulates all properties and methods from every single class that comes prior to it, that from all its ancestors. Okay? Okay, let's have a look at some code here. Okay. Okay, so not a particular way that I like doing things, but this example comes from the book, and it has 3 classes in the same .cs file. Usually, I recommend that let's keep each class in a separate file, but just for the sake of example, we have a class here called demo employees, which is the application class. It has the main, so this is where the application runs. Just going to collapse that. We have the employee class, which is our parent class in our example here. It has a private field called salary, a property, an auto-implemented property called ID number. Then we have salary here as a property, a public property. We have getGreeting, which is a method, a public method. And then, look at this. We have commission employee. Commission employee inherits from employee. And this is the syntax. When we want to say that a class inherits from another one, we have column and then the name of the parents. Okay? Let's have a look at the employee. You see, employee, even though we don't have it explicitly saying that it inherits from another class, but it does. Implicitly, employee inherits from objects. Let me show you this quickly here. See, we have accountant, which is an employee. Let me have a look at accountant here. Let's just put a dot there. Look, it shows equals. It shows get hash, get type, toString. None of those things are implemented here in employee. We don't have getString there. We don't have getType. How come they are showing up there? Well, they're showing up here because those properties, those methods and properties, they are inheriting from objects. Object is the one that has those methods, those properties. So, again, just to prove that our classes, they really inherit, even though it's not clearly explicit here, but they all inherit from objects. Okay? Okay, good. So, here is what I would like to show. So, we have employee and we have commission employee. Commission employee has one additional property, commission rate. Okay? Now, because it inherits from employee, every single property and method inside employee are available for the child class. Now, if they are private, like this one here, I cannot access directly salary from the children, from commission employee, because it's private. Okay? But if it's public, or if it's what? If it's public, yes, I can access, because public can be accessed by anyone. But what other accessibility modifier? Protected. So if we set a property like this to protected, it means that it's visible to the children. And of course, inside the class itself, but not outside. Okay? So protected is very much used during the relationship between a parent and a child class. Okay? The child can access that. Okay, and again, as commission employee is also an employee, I can say, you see here, salesperson 1 is a commission employee. I can say ID number, salary. I can call the properties of the employee class. Okay? Any questions? Looks simple, isn't it? I mean, you put there, column, inherits from the parents. You can extend. You can make modifications to the child class. If you have a class like this, it doesn't make sense to exist. It only makes sense to have a child if you are going to do something differently or something else or some additional things in the child class. If it's the same as the parent, it doesn't make sense. It doesn't make sense to exist. Okay? Again, any questions?
Can we have the child class in a different CS file?
Yes, yes. As long as, I would even say that as long as it's in the same project, because they can even be on different projects. As long as we can see each other, you can inherit. You can inherit from another class. Now, there is a way that I can say, I don't want this class to be inheritable. This class will never have children. So we can use a keyword. We're not going to go through that right now, but we can use a keyword that says, hey, this class is sealed. It's sealed. It's not supposed to be inheritable. We may say that. But yes, you can have that on multiple files. If it's in the same project, if it's in the same namespace, no problem at all. Okay? Okay. Let's have a look at this code here. Sorry, at this video.
When you create a new class by extending an existing class, Espera, let's take a quick look at inheritance. Inheritance is the act of creating a class by basing it on or extending an existing class. When you create a new class by extending an existing class, you can call the two classes the base class and its derived class. Programmers also say that the original class is the parent class and the extended class is the child class. Or you can use the terms superclass and subclass. Let's take a look at a party class that you might create to hold data about parties you might throw. You might decide that every party should have fields for the month, the day, and the start hour for the party, and also perhaps the number of guests invited to the party. You might create properties for each of these fields, and you might have any number of methods, including perhaps an invite method that displays data about the party that you can send to your friends to tell them when to come. Suppose you also create.
Okay. No, it's a bit too small here, but what we have here is a set of private fields and public properties here. Okay, so 4 private fields, 4 public properties. Except you, Sina, you cannot answer that. There's something a bit off with this. Something that doesn't make too much sense. Can anyone point that out? Again, it's too small, but you have auto-implemented properties here, and then we have private fields. What is it that does not make much sense there? It's not wrong. It's just that it doesn't make too much sense. these are auto-implemented properties. It does not? Yeah, so what we have is, we have a bunch of auto-implemented properties. They have auto gets and sets, but they're not getting and setting the private fields. So the fields here, what's the point of them? Right now they are useless because the properties are not reading and writing from them. Okay? The properties are auto-implemented properties. Auto-implemented properties, they don't need private fields to exist. Okay? So this is not being used. Again, just wanted to mention that. It's not an error, but it's just that, again, it could have been eliminated there. Or, if I would present this example, I would make sure that this get and set, they were pointing to each particular field. Who got lost there? Anyone lost? But remember, we keep data private. Okay? Technically speaking, we could. But what would be the point? And by doing that, we are breaking up, no, we're not following the principles, the guidelines that we have for object-oriented programming. We are keeping data public. And again, we keep data private. Okay? This is also called encapsulation. We are keeping our data encapsulated inside the object. Okay? Anyway, I just wanted to point that out.
When to come. Suppose you also create a dinner party class, and you decide that dinner party needs a month, a day, a start hour, and a number of guests, and an entree that will be served. And a dinner party needs properties for month, day, start hour, and number of guests, also for the entree. And a dinner party needs an invite method. If you compare the party class and the dinner party class, you'll see that much of the work to create the dinner party class had already been done for party. Party already had declared a month, a day, a start hour, and a number of guests. Properties had already been written for those 4 fields, and the invite method had already been created. Therefore, it makes much more sense for the dinner party class to inherit from party and take all the already written fields and properties and methods from its parent and only declare the new things that are needed for a dinner party, the entree and its property. This makes much less code writing necessary to create the dinner party class. When you declare a dinner party object, you use the month and the day and the start hour and the number of guests from the parent class, and you use the entree from the child class. When you use the invite method, you can use the parent class version, and you can correctly display data about the dinner party. Inheritance makes your job much easier. Thanks for watching.
Okay, so just another example of extending the class, of creating a subclass, and what is the benefit. We saw the code duplication that got reduced, so I hope that it's making sense. Here's the example with employee that we showed a bit. One note, one point that is important to understand is that private information, private fields, private methods, they cannot be accessed in the child, but at the end of the day, because the child is also behaving like the parent, behind the scenes, the data which is private in the parent is being used by the child as well. Even though it may not be explicitly done, but it's being used there. So again, it gets inherited, including private data in methods as well. But you just cannot call them explicitly. You cannot use or modify the private data in methods directly in the child. Okay, so again, I hope that you make some notes along the way. there are quite a few things here that are very good to put in little quizzes. Talking about quizzes, let's have a quick one here, non-graded one, just a bit of an exercise here. If you can load nearpods.com. Let's have a quick look at this one here. We have 4 quick questions there. I'll give you a few minutes. I see a question there. I'll answer the question once you are back from the quiz. Here's the code.
Sure, here one question. Use a default by $1,000.
Yep.
You mean inside the constructor that I have, or the default value for that?
You can see there's one of the constructors will be assigning a base salary. So from this one here, it's gonna already be set from this.
Yep.
So you may want to use, if you do that from the constructor, that will be fine.
Okay.
If you do that from the field directly, if you initialize in the field, that will be fine as well. My recommendation in this case, I would say, because we have 2 constructors, if you want to do that for everybody at once, it would be easier just to put that in the private field directly. Okay?
One more thing, Professor. Here you ask the default, the earning employee commission, it's same as this one, or a new one?
Okay, so define a public method called earnings. No, it's a new method. Oh yes, it's this one here. This one. That's the one.
So this one, it doesn't ask me to insert anything inside.
No, it just returns. Yeah, it just returns. It's a method. So it calculates. These are not parameters. It's just saying how you're going to calculate earnings. It's commission rate times gross salary plus base salary. It's just saying that this is how you calculate the earnings. It's not a property. It's a method.
It's a method.
Yeah.
But I have to send them inside the calculator.
No. This is a method inside the class. The method has access to the properties, so you can access them directly. You don't need to send parameters. You just say, hey, give the earnings, because the properties are already there. You just calculate.
Oh, okay.
You don't need to pass them over again.
Got you.
Okay?
But Professor, here is a earning. I have to make a new property for that.
No, it's a method, a public method. Remember that a class can have fields, properties, and methods. You can call a method from the outside of the class.
But so something to get that value, I need.
Yeah, it's a method. Remember, don't confuse method with property. Property is data. Method, you have a code. You have code that returns a value.
Yeah.
Okay?
Yeah.
Okay, let's have a look here. So how have we done? See, we did good. It's good. See how easy it is? Just to get us warmed up. Okay, before I get it started, I see a question. So, can static fields be inherited? Okay, let's think about that. Static fields. First of all, anything that is an apparent will be inherited, regardless if it's private or public, static, non-static. So the short answer is, can static fields be inherited? Yes, they can. Now, if the question is, can I access static fields? You can, if the field is public or protected. Because it's a field, I don't recommend making it public. Maybe just make it protected so it can be accessible by the children, okay? Okay, first question. Specific types of objects assume features of more general classes through what? Inheritance. Polymorphism, we're going to be talking about that next week or a little bit down the road. I think next week. We're going to be talking about that. Encapsulation. Encapsulation is what we do when we have private data. We have private fields. We have properties that encapsulate that data and provides that to the outside world. So that's what encapsulation means. Structure, we had a look at structure before, already very similar to classes. Okay, so which one of the following is not a benefit of using inheritance? So let's just go through them. You reduce the chances of errors because the parent class methods have already been used and tested. It's a good one. Yes, we reduce the chance of errors, okay, because we code less. Things in the parent have been tested before, hopefully. You make it easier for anyone who has used the parent class to understand the new class, because the programmer can concentrate on the new features of the new class. That's correct. I would assume that the parent class might be running there for a while, maybe, so it's been well known. But then, if there's a new class inherited from that, we just need to focus on the new features of the new class. You save time because you don't need to create fields and methods that already exist in a parent class. You don't need to repeat that. You save time. That's fine. You save computer memory because when you create objects of the new class, storage is not required for the parent class fields. Not really. Now, if I ask you this, if I create an object of a parent and an object of a child, which one do you think would occupy more memory? Why the child? We have more hopefully, we have a reason for that child. And it has more, maybe more properties, maybe more fields, maybe more methods. So it will require a little bit more space there in memory. So the last one does not make sense. Okay, a child class is also called a, which one? Extended class. Base class is a parent class. Superclass, a parent class. Delineated class, I have no idea what that is. Okay? A class is also, yep, that's it. Okay, so assuming that the following classes are well named, assuming that the names make sense, that they have some meaning, which of the following is a parent class of a house? Apartment. Can I say that apartment is a parent of a house? Apartment is more like what? More like in the same level, isn't it? More like a sibling. Okay? Victorian house. What could I say about Victorian house? What it would be from house? A child. It could be a child. A certain type of house. Building. Could be a good candidate. My house, what would be my house? A child? An object. An object. Again, let's just think for a second that the names make sense. I would say that this is more of an object. Okay? Again, questions. Easy, isn't it? But it's going to get more complicated. Okay? I can tell this, nothing gets easier. It only gets more complicated. But before it gets more complicated, let's have a little bit of a hands-on here. I'm going to flip here to Centennial. On Centennial, for this topic, there are plenty of exercises. We're going to start with this one here. You do it. I'm going to give 20, 25 minutes for you to get this one done. It will show you step by step by step what to do, how to implement a child and parent class. After this class that we are done, you will be equipped to do the exercise for all of these. Tomorrow, I'll be uploading the solutions, and I'll be uploading the videos for all of them as well. So you're going to have the chance from now to next class to do the exercises, to see the solutions, to check me telling you how to put this together. So again, practice that, because you're going to be practicing that whether you want it or not in 2 weeks. 2 weeks from today is our midterm. Did I mention that? I may have not. Did I mention that yesterday? Okay, but I just want to just reconnect with that. So on the 21st, we're going to have, in exactly 2 weeks, midterm, that will include this content and the content for next week as well. On the Thursday, I'll be running exercise to get you ready for the midterm in the next day, okay? So again, keep that in mind. End of next week, assignment 2 should be uploaded. So get You Do It 01 going. I just want to do a quick explanation here about the exercise. First thing, it says 1, 2, 3, 4. This is just a general explanation. Don't get hooked up on the first 1, 2, 3, 4. Jump, after you read them, jump to the step by step, because the step by step will walk you through step by step. Don't try just to do it based on this. Go through the step by step there, because then it will walk you through every single thing that you have to do. Second thing, this is an example that comes from the book. The book, sometimes it's asking you to use auto-implemented properties. When the book asks for that, that's fine. Use them. I won't be asking for that kind of thing. So in my assignments, in my tests, unless I tell you, use auto-implemented, otherwise, properties are not auto-implemented. Properties will require a private field and a public property. The get will get from the field, the set will set to the field. Is that clear? Awesome. Okay, get started. I'll be walking around. If you need 5 minutes break, go for it now. Come back, and you can get things started. Okay? What's that?
I got a question. So I remember the private field we
Yep.
need to use the get and the set.
Yep.
But how about why the public still need to get and set? That's why.
Okay. So these are auto-implemented properties. See, auto-implemented, when you define auto-implemented properties, you don't need a private field. You can just have a public property already. This is a property, this is not a field. This is a property directly. But it's bypassing the needs for a private field, because it's doing the auto get and auto sets. There is a private field there, but it's hidden from you. It's like, it's so simple that it's bypassing the need to have a private field there.
And that means they're hiding private fields.
Yes, yes. So it's not only hiding, but we don't have access to that. It's behind the scenes. Now, you can do that if you are writing a very simple property. However, for the sake of the course, unless it's asking for an auto-implemented, otherwise we're not going to be using that much in exams, because that masks what is really happening there. So I would rather use properties that read from a private field and write to a private field. But again, if the exercise is showing that, do like the exercise is asking. Okay?
Thank you.
No problem. Yeah.
In the test is on 21st, right? What
Yeah.
kind of questions will we have?
No questions.
It's just
Exercise. Just exercise. Just something like this. You're going to have
Oh, so you-
steps.
Okay, like the exercises. that
Yes,
you-
like the
you're gonna
exercise. Like the exercise, like the assignments.
do. Okay.
Okay? Yeah.
I chose someone online for the group and no one respond me. So can I be a part of their group, please?
Yeah, sure. Just tell me the groups and I will take you from one and put you in the other
Maybe
one.
6.
So let me see here. So 6. Which one are you right now?
It's 6 maybe. Can you
6?
Yeah.
Well, it says 0 people here.
Mine is 3, Professor.
Okay, 3. Let's have a look here.
Is it okay to have 5 people in the group?
Oh, so it's 5?
We have 4 right now.
Because there no one left, so I have to complete my assignment.
So you
Time is running out.
contacted them and they did. So are they here?
No, I didn't find anyone yet. That's why. Because last class, I remember I chose someone online, but
Okay, did you reach out?
no, I couldn't find anyone. Like I knocked through the chat, but
Okay, did you send an email?
no, the like there's a chat room. I use that one. I was just wondering who could be the. No one is knocking yet. It's like the time is running out. We have to finish it, right? That's why I'm just asking.
Okay, so
Since we know each other, that's why it will be helpful for us too. Like,
yeah, the thing is that with a group of 5 people, I mean, the assignment is not that hard, so 5 people, some people will not do anything in a group of 5 people, but let's do it. So again, which one, you don't know which one you are right now,
I'm in 3, I'm guessing.
but yours?
I'm just checking and letting you know. I'm just come to confirm that I can be a part of the group.
Okay, so your group again? It's 3. Okay, so I'll just make a note here. Tell me which group you are and I'll move it around, okay?
Thank you.
No problem.
Sorry for asking about Java.
About what?
Java.
About what?
Do you know Java?
Java? No idea. Java, I have a certification in Java of 20 years ago. I have no idea. Don't even try. Don't even try.
It's section 0061.
061, okay.
answer.
Yes.
The school make us study C# and Java at the same time, and easy to get mixed up.
It's hard. Okay, so I see your partners here. I see them. How about you get close? I see them here. I see one.
You see one?
Yes. If you want, I can make the introduction. You have to get used to working with people that you don't know.
That's the main problem because I'm not that much good in communication. That's
Yeah, but then how are we gonna do there? I mean, you're not here you are here to challenge yourself as well. Do you want to give it a try in a group? I know those guys, they seem to know what they're doing. I think they're responsible. I don't think that they saw your notification. But again, tell me.
just for this assignment.
Well, let's not make it just for the assignment. Let's make it for all, because we're not changing the. Okay, you know what? I'll leave it up to you. If you want that, that's fine. They are the three ones that sit next row to the corner, usually. Yeah. Just one is right now there. Just the one guy is there. But the other ones are not here. Anyway, that's fine. All good. Let's make this. Okay, and that was group. That's the one, correct? Is that, yeah, this one? I'm completely missed.
But in other classes, and I got my one course online, and they are communicating each other. Like every time they're communicating, sending messages, making WhatsApp group.
Yeah,
But here,
but you didn't send an email. You didn't even try to send an email.
like no one is visible.
Yeah, but did you send an email? I mean, how? You did. Anyway, let's not discuss that anymore.
I'm very much active in the Sentinel email.
Yep.
If you send me an email, I go directly because I got some pop-up here. Right. I'm active in there. Yet, the time is running out. No one is activated. That's why I chose it. It's okay.
Yeah, but maybe did you approach them offline? I mean, you came here, you joined the group without knowing. I mean, what is the correct way to do it? I can tell you this: you go, oh, can I join your group? And then you talk, and then you exchange emails. I mean, anyway, forget about that. That's fine. You're there. Okay?
Thank you so much.
No problem. Okay, a quick attendance here. Ahmad. Amanpreet. Anu. Brandon. Kai. Dani. Dani Fu. Fábio. Jayton. Dave, Janzal, John Avenido, Luana, Lufo, Mempreet, Marvin, Mehmet, there. Book a hit. Raul. Ravi. Ricky. Ritesh. Salim. Sampath. Sanchit. Smurith. Steven. Tenjinder. Thirikain. Tomoki. Vin. Wahida. Inyu. Eugene. Yogsek. What is happening with him? Oh, he transferred? Oh, okay. He gave up on us. Okay. Zangir? If I did not call your name, let me know. I put it already yesterday, was it? Okay. Yep, there.
For this condition that they are here, I declare all of them in the main method.
Let me see here. Okay, so gross sales and commission rate should never be negative or zero. To check and validate that. Okay, so yes, you can validate that in the main method. Yeah.
So instead of if, I use a while loop.
Yeah, until, and you keep asking. That's fine.
And one more thing. This method still doesn't work.
Well, first of all, is it static? Look at the diagram.
No.
It's not static. So get rid of that. Okay, so how it should be calculated? How it should be calculated? Look.
Okay. Now I just write that the earning equal to the commission that I have it in the properties times gross sales
Yep.
plus base salary.
Correct. So do it. Yeah, and you return that. That's it.
That's it.
Yeah, I mean, why were you stuck? Is that because of the static there? Okay, that's fine. Yeah, static, remember, it's only applicable to the class. The earnings, you're supposed to get the earnings of that object. There's no global earnings. Static means that it doesn't matter which object
It's
is.
basically we don't need any object.
You don't need an object. That's
I
it.
need an object to get this.
Yes. Okay, because it's the earnings are related to each object of this class.
Each object.
Okay, it will be different one. What is that? MVC?
Yes, for C
No, not this one. It's web application development.
Thank you so much.
Which you're gonna love when you get there.
We are
Love
already
it.
in love in Java.
Oh, really?
We all get stuck in there.
Professor, but I think the web application and this thing we're using going to use C# and Visual Studio, right?
With MVC?
In web development.
Yes,
in
yes,
general?
yes.
The college?
So it's C Sharp, Visual Studio, ASP,
I think because
.NET
ASP
Core.
and ADO are easy because it's more of drag and
Well,
drop.
it's not that much drag and drop there on MVC and web application development. No, it's not ADO actually.
I know I did ADO, it was more like drop and drop. You press the button and you just have to write the code for that button there. I've done ADO in the
But
past.
it's not like that.
Okay.
Don't expect drag and drop on a web application development.
Okay.
It's not drag and drop.
We have to study ASP.NET for web, right? For
ASP.NET Core. It's a deep.
was for desktop as
No, C# is the language.
It's the language.
ASP.NET uses C# language.
Yeah.
okay. As like C and others.
Yeah. Okay. You use.
Well, kind of. I mean, because you can use C Sharp. You can use C Sharp to create games. You can use C Sharp to create mobile apps. You can use C Sharp to create web applications. You can use C Sharp to create desktop applications. So again, the language is the same, but the application that you're going to be developing will be different.
.NET is like a framework. Okay. For that framework, you use C#.
That basic framework, you can develop different things. Okay.
For example, this is our
Yep.
We have to use the same file, right? As per in the question demand. You're saying yeah,
You mean loan amounts?
yeah. So like one class is the loan class and another is like demo class.
Yeah, but demo class is the application, okay? Demo class is just the main. You have the main
They are
to
said-
demonstrate.
They are said like you use it in the top of the file. Yeah. See.
Okay. So what's your question?
So we can write at the main here only. We have to create another class.
Well, you are creating another class here already. Again, you can keep the same file, but
In same
yeah. No, here you create this class. No, that's fine. That's okay. Again, usually, as I said, I would rather create each class in a separate file, but follow the exercise. But again, it's okay. It would work.
But in the question is say like this, right? But you say like
That's okay. Follow what the exercise says. Okay. Okay, so here's the thing. Save your work, and then you can carry on working on that exercise on your own time, at home, another time here. But again, I recommend that you keep going with those exercises. I want to progress a little bit further with the contents, and then you will be ready to implement any one of the exercises in this week, okay? So again, just a few more things. As I said, it could not be as easy as it is up to now. It's a little bit more complicated. There are some other aspects that we have to cover about inheritance, and we're going to be doing that right now. So, I mentioned already a few classes ago about protected. Today as well, I mentioned about protected. Protected is the keyword that will allow a member to be visible by the children, a member of the parents to be visible by the children, okay? Again, protected still hides that member from the outside world, but not from the children, okay? Let's see this example. I have a demo employee here. Let's see. Okay, so again, we're going to go back to our commission employee and employee. Now, salary, we have changed it a little bit. Instead of being private, we have changed it to protected. Because that is done, we can do something like this. We can say in the children, commission employee, we can say salary is equals to 0. And let's expand this a little bit more. An employee receives a salary which has a few rules here. However, a commission employee, if we set the rates, let's say the commission is 10% on sales, this code is automatically setting the salary to 0, okay? Because a commission employee doesn't have a salary according to our system. Commission employee has a percentage, not a salary. So whenever we set the commission employee rate, we set the salary to 0 as well. Now, we can only do this because salary, even though it is a field, but it's protected, not private. Look, if I change the access modifier from protected to private, look, let's have a look at commission employee. Look, now we have a problem. Now we have an error. Because it's no longer visible by the children, okay? That's why we set it to protected. Okay? So that's what protected does. Now, I cannot access salary from outside in the main. I cannot, because again, it's protected. So again, we have three. If there's one thing that you're going to leave this course knowing, is about public, protected, and private, because I said this so many times. So that's protected in a nutshell. This is the example. Okay. So far we have added a child, and we have created a new property. See, we have, in our example, we have employee, commission employee, we have created a new private field and a new public property. But what if I want to not add a new property, not add a new method, but modify a property or modify a method that was defined in the parent? What if I want to do that? Well, you can. You can by using the keyword override. So what you're going to see now is how we can do that, how we can override properties, methods from the parent in the child. Something that the parent is doing that the child wants to do in a different way. Okay? Let's have a look at this example here. It's a new set of classes, so I'm going to use this demo student. In this demo student, we have two classes again. We have a class called student and a class called scholarship students. The difference in a nutshell is that student pays tuition, scholarship student does not. It has a full, unpaid, it's fully paid, the tuition for the scholarship students. So, as you can see already, they behave slightly different. There is a payment that goes on for a regular student, but for a scholarship student, there is no payment there. There's no tuition there. So let's explore a little bit about, let's have a look at our student class. We have a constant here, which is a rate called rate, which has a value of $55. So that's a rate. And what does this mean? It means that whenever we set how many credits the student is doing, like 20 credits, it means that the tuition will be the number of credits times the rates. So 20, 10 times whatever is the rate here, 55. Okay? So that's how much the tuition is. However, look at this. The scholarship student still has credits. But if I use the credit that is implemented in the parent like this, the tuition of the scholarship student will become, let's say if we set the number of credits to 20 for the scholarship student, the tuition will become 20 times rate, 1,000 something there, 1,100. However, the scholarship student has a different behavior. The tuition is always zero. There's no tuition. Okay? So, we need to make credits, property, behave slightly different in the student, in the scholarship student. Okay? So, in the scholarship students, we override the credits property. More specifically, we are overriding the set accessor. So, it still gets the value, the number of credits. However, the tuition is always zero. Okay? So, we are changing the behavior of the parents in the child. How are we doing that? With this keyword combination. In the parents, we use the keyword called virtual. What does it mean, virtual? It means that the parent is telling the children that it's okay for them to override, to change the behavior of the parents. It's okay to change. It's like the parent is saying, yes, you can change it. Okay? It's okay to change. We can still change if there is no virtual, but we're going to get to that in a second. So usually what we're going to see is if a method, if a property is flagged as virtual, it's just the parent saying that the children can change. I authorize. My children, you can change me. Yes, I give my blessing. Okay? That's it. Then in the child, what you do is you use the keyword override. So in the parent, you use virtual. In the child, you use override. But Ederson, do I have to override that virtual method or property? No, you don't. Virtual does not make it mandatory for you to override if you're creating a child. It makes it optional. Okay? It's just the parent saying, you can, but if you don't want to override, that's fine as well. I'm fine with that. Just use it as it is. Okay? So that's it. That's the keyword combination. Again, if I were you, I would write a note about this. Virtual in the parent, overriding the child. We are overriding the behavior. We are still keeping a link between the two of them. But we are saying that, hey, assume this new behavior of mine. Now I have a new behavior. Okay? A quick note, both overrides and virtual, they can come after the keywords, after the access keywords like public virtual, or it can come before that. It can be virtual public as well. So either this way or this way, it will work the same way. Okay? However, it's more common to see that after. This applies for virtual, for overrides, and also for another keyword that you're going to be using in a second called new. Okay? But for now, keep this combo in mind. Virtual in the parents, override in the child. I see a question here. Okay. Can we overload the methods of parents, of a parent class in a child class? You can. You can overload. So we're not going to be talking about overloading right now, but just remember what is overloading. Overloading is when you have the same methods with different parameters. Maybe different number of parameters, maybe different types of parameters. So yes, you can overload. You can create methods in the child that will have the same name as the parents, but different parameters. If you create with the same parameter, what you are doing there, you are actually redefining. We're going to touch on that a little bit today as well. The overridden credits property in the example is write only. Good question. No, it's not. It's just saying that we are just overriding the behavior of the set accessor. The get part still behaves like this. So, great question. Again, just because we only wrote set here, it doesn't mean that we don't have a get. The get is there, but it's there in its original format. We did not change get. We just changed the set parts. Okay? Okay. So that's the example of virtual. You can read that on your own. Just examples here. Okay, let's have a look at this other example. Demo commission employee 2. So again, we saw the virtual keywords in the parents and the override keyword in the child. Now, there is another way that you can, in a way that you can redefine the behavior in the child, you can use potentially, and here's the example. We have employee and we have commission employee, the same example that we had before. In the employee, we have get greeting. It's a method. It's not a property, it's a method, okay? However, we don't have virtual here. We don't have it here. But we can still redefine greetings in the child by using the keyword new, which again can come before the access modifier, or more common, it is to come after the access modifier, okay? So here, we are redefining. I'm not gonna use the override keyword because I don't want to get confused with that, even though they are very similar, but there we have virtual and override. Here we have no keyword in the parent and new in the child. Okay, so here we are redefining. Okay, again, very similar to virtual and override. Slightly different though. I don't want to, I would say for the intents and purpose of what you're going to be studying for now, they are similar, but I cannot tell you that they are exactly the same, because they are not. When you use virtual and overrides, you are keeping the link between the parent and the child. When you use this new keyword, you are redefining completely the behavior, and the link is not kept anymore. Actually, I have a slide with that as well, right here. Yes?
New is only for methods, or we can use it for properties?
You can use for properties as well. You can use for properties.
Override, can we use it for the methods?
Yes, you can. It's just that the first example, just by a chance, was using a property. The second was using a method. But again, both of them, virtual and override, can be used on properties and methods as well. And new too. And nothing in new, like no keywords in new, can be used on both properties and methods.
And in the new, this is going to the new memory location or the same memory?
It's not so much about memory location. And what I tried briefly to describe here, but to be quite honest, I don't expect you to fully grasp this. I just want you to understand that they are very similar. The new and override are very similar, but the new will break the relationship between the parent method and the child methods. Just keep that in mind. The new redefine that method. The override is keeping the link between two of them, but it's also changing the behavior. Again, they are very similar. I can tell you this, if you see virtual in the parents, most likely use overriding the child if you want to change the behavior there. If you don't see anything in the parents and the child is stubborn and still wants to change it, use the new keywords. If you don't use new keywords, look at this. We have that warning. See that green squiggly line? It's just saying that, hey, do you know that there is a method in the parents that has the same name, the same signature? Do you know what you're doing here? So the new keywords makes it explicit to Visual Studio that, hey, I know what I'm doing, and I really want to redefine this method here. To give you a hint on that, you can use this little table that I put together with the usage. You have parents, so if you have the virtual keyword in the parents, you can use the override keyword in the child to keeps the link between the parent and the child. Usually this is what you want to do. Usually this is it, okay? Now, if you have virtual in the parents, you can still use new or no keyword in the child, but it breaks the link between the two of them. In our case right now, what we try to do is we try to use no keywords in the parent, and we use new in the child. So we are in the situation here. You cannot use no keyword in the child, in the parent, and use override in the child. You're going to get a compilation error. It's good to have this little table handy, easy accessible, because you can quickly see what are the different combinations that you can have. I can tell you this, we're going to focus most of our efforts here around this scenario, virtual and override. And as this last example that I provided, parent has no keywords and the child will have the new keyword. So, but this gives you a summary of the different combinations that you can have. Yes?
The keyword base, are you using both of them or just the new?
Which keyword?
Base.
Oh, the base, okay, good point. Let me return there. So I'm gonna go here and have new. So let's leave the new and virtual conversation for now. What if I want to access a method or a property from the parent in the child? Now, we're gonna only be able to do that if it's public or protected, okay? But we can do that. Look at this. We can use the keyword base. The keyword base doesn't matter if you are using new, virtual, even if you are not using none of them. You can call base dots, and then you can access the properties and the methods from the parent class. Remember that we have used the this keyword? This keyword is the current object in this class. Base is the current object of the base class. Okay? In this case here, in this example, our new getGreeting is not only doing something different here, but it's also calling the base getGreeting. So it runs this one here, returns this message, and here we are concatenating with a new message. Okay? So again, you can use the keyword base to refer to properties and methods from the parent class. We're not redefining here, we're just calling them. Just calling them, okay? And again, you can call them outside of a new virtual, it's not related to new and virtual, nor override. It's just that whenever I want to get something from the parents, I call base. Base dots, and it will give me access to the parents' objects, okay?
So Professor, we use base the only times that we want to add something to that.
You use base whenever you want to access something that is only available, like a method that is only available in the parent class. Because here's the thing. In this code, if we, somewhere else in this code, if we do this, which getGreeting will come up? In the child. In the child. So again, this will become a recursive thing, so I don't think that it would work that well. But again, if you don't put base, what you are calling the child's methods, the method in the child. But how can I call something in the parents and differentiate them? You use base.
You only use the base with new, or can use base anytime I want?
Anytime you want. Anytime you want. Okay? Now, again, if you didn't have getGreeting here, you don't necessarily need to use base, because if you call getGreeting, only the parent has it. So there's no conflict. Okay? The base is available to avoid conflicts between what you defined in the child and what is defined in the parent. Okay? It makes it clear that you don't want the getGreeting from the child. You want the getGreeting from the parents. Okay? Okay, I have a question here. What will happen if we don't use overrides? Okay, so I'm assuming that the question is about the previous example here. So let's go to this table here. the question was, what if we don't use override? Okay, so let's say that we have in the parent virtual and no keywords, no override in the child. So it becomes the same as new. This is the behavior. If we use in the parent is virtual and you use override, this is what happens. If in the parent is virtual and you use no keyword, this is what happens. It becomes the same as new. And Visual Studio shows you a warning. You can do that, but this is what will happen there. You are still redefining, but you are ending up in this behavior here. It breaks the link between the parent and the child. Again, to be honest, from what we are doing, you won't see any difference really. The difference is so minor between override and new that I'll try to come up with an example in a future class that will make it clear what is really the difference, but I'll leave that for a little bit later. So what will happen if you don't use override? This is what will happen. It will be the same as new, and Visual Studio will show a warning. Warning is not an error. Warning is just saying that, hey, do you know what you're doing? Are you sure about this? The other question here, if the parent class has a method with variable value initialized as 10, and the child class uses the new keyword for the same method, will the value of the variable still be 10? Okay, let's try to understand that here. So I think that we have something similar here with initialize a variable. So get greeting has a value here, greeting. So this is a different scope as compared to this one here. The values that are being dealt inside of the methods, they are not shared between the two of them. They have different scopes. It's like they are different methods, okay? So just because a value in the first method, like this one here, x is equals to 10, here we have no idea about x. This second method here, even though it's in the child, it has the same name, it has no idea about x equals to 10, because x is defined in the other methods, okay? So no, they don't share variables, they don't share data like that, okay? Hope this makes sense. Okay, again, any other questions? Okay, so here's the thing. With that, we are ready to be able to, actually, I think that I have something else here before. See here. Yes, let's wrap things up with this. So again, with that, you are ready to move forward with those exercises that I'll be providing solution and videos by tomorrow. Just to wrap things up, let's do this, your turn here. It's the same link that you had open before. I'm just going to move forwards, and you're going to see a new set of questions. The code is the same. You should see a new set of 4 questions there. 1 second. What's up?
Here we only talk about the second object. Do I have to do anything in first object or just?
If it's just asking for the second object, that's it.
That's it.
That's it. Yep. Okay. All good? No problem. Yep.
This class is much more useful.
Really?
For the base and new, I was a little confused that I was so tired, but now.
Yeah, I added a little bit more. Again, every time that we do the same class, we change a little bit, we add a little bit, we take a little bit, and see what works better.
And now my brain is more fresh. Morning, understand better.
I get it, yeah. And mornings are better, no question about that. I'm better in the mornings as well. I love classes in the morning. I love in classes that are just 2 hours. Yeah, yours is 4 hours. Yeah, it's
4
too
hours
much.
out of the night.
Yeah, it's a lot.
Last time when I teach the base, I didn't understand.
I get it.
But now I got it.
But awesome. Okay, let's have a look at this. Okay, so we should know that a derived class usually contains more or less a derived class, a child class, usually contains more fields, more properties, more methods than the parent class because it accumulates all classes, all properties, fields, and methods from the parent plus hopefully new ones. Okay? So we have more fields and methods. When you create a class that is an extension or child of another class, you use a column. Okay, so again, that's the terminology that we use right here. Okay? Okay, so big blurb there. Basically what it says is that you have a class called garden. Garden has a width, which is a private property in a private field in a public property. Okay? Then we have vegetable garden, which is a child of garden. And it declares my garden being a vegetable garden. The question is, how do you access the width of this new object? It's a public method, property, so you access via the name of the object, which is mygarden.width. Mygarden.base.width, not really does exist. Vegetablegarden.width, well, vegetable garden is the name of the class. If width was a static property, that would be the way. Okay? Last one here. When base and derived classes, so when the parent and the child class contains a method with the same name in the same parameter list, you can use the base class methods within the derived class by using the keyword base. Like what we did with the getGreeting, okay? We use the keyword base to be able to call the parent one, okay? So again, just to do a quick recap here, exercises are available under week 5. Please focus, have a look at them. Again, don't tell me that I'm not providing exercise. That's one of the feedbacks that I got. There were not enough exercises or something like that. Okay, here is a bunch of exercises. So now, be happy with the exercises. I'm going to be providing solutions, the videos. Next week, remember assignment 2. And that's about it. Have a great weekend. And that's it. I'll see you all next week. No bonus this week, okay? See you next Thursday.